hour. So we can go ahead and kick this thing off. Again, thanks everyone for being here. We're going to be talking about agentic workflows and talking about Mastra and how you can build agentic workflows with Mastra or, maybe without Mastra too. We kind of talk a little bit about just agentic workflows in general as well. So I'll share my screen and we will kick it off. But this is live. This is meant to be interactive. So if you do have questions along the way, you can drop them in the chat. The chat sometimes gets a little busy though, so if you do want, if you really have a question you want answered, please use the Q&A section. It's a lot easier to kind of filter through the ones that are just, general fun chat versus actual questions. So please use that, and I will stop a few times throughout this, and we can answer questions. We can kind of have discussions. It's meant to be pretty interactive, and hopefully, we can all learn some things about how to think about building agentic workflows and agents and really just implementing these new technologies into our AI applications. And so with that, just go ahead and kick this off. Hopefully you can all see my window here. And if you can't, please, let me know in the chat. But let's go ahead and talk a little bit about what the goal is of this workshop. So we're going to build agentic workflows with Mastra. We'll talk about what is an agent, what's a workflow, how do we think about these terms, and how do we actually then build something that's usable or useful. So things we'll cover: why do agentic workflows exist? How do workflows compare to agents and multi-agent networks? We'll do a demo of workflows in Mastra and actually look at some code, which, just to answer the question, like, will the content be shared afterwards? Yes, it's live right now on YouTube. So if you go to the Mastra-AI YouTube page, you would see it live, but immediately after this content is available. And we will send a follow-up email for anyone that did register for this on the Luma event. Within an hour or two, you'll get a follow-up email with links to the presentation as well as links to the GitHub repo that we're going to be talking through today. So you can actually download it, try it out, play around with it. So who am I? I am one of the founders and I run product at Mastra. I was previously at a company called Gatsby, and then we were acquired by Netlify. I built a service called AudioFeed. I've been spending a lot of time in open source software back when I first started building Drupal websites and kind of contributing to the Drupal community back in the web development days of like 15 plus years ago. So been doing open source software for a long time. And yeah, please connect with me, smthomas3 on X or Twitter, or connect on LinkedIn as well. So we do have a question. I'll kind of answer as we go. Can Mastra be integrated in a React app like a chat window as a separate app or inbuilt? So the answer is it can be done in both ways. You can actually integrate Mastra directly into like a Next.js site that has a chat application, or you can use a separate app and use Mastra as kind of the back end of the AI application. So you can kind of do it, you can architect it in both ways. And there are pros and cons to each approach depending on the scale of your project and how you want to deploy your code and all that. But ultimately it can be used in both ways. All right. So oftentimes when you're thinking through how to build an application that maybe uses an LLM. That's what a lot of people end up doing is we've seen what these tools like ChatGPT can do, and now you want to add features from those types of tools, these LLMs, into our applications. But how do you actually architect it, and what can you do with it? Because oftentimes you've probably all seen it that these LLMs aren't always perfect, right? Sometimes they hallucinate or make wrong decisions. And so how do you work with a system that is more probabilistic, not deterministic? And if you're a software engineer like me, it's kind of hard to think through things that you might, sometimes 1 + 1 is 3 in the case of LLMs, right? Where it's not, the same input doesn't always lead to the same output. So you have to balance flexibility with reliability. And so as developers, we kind of need more control. We can't just let the LLM do anything. We have to put it kind of on guardrails. So LLMs are still improving, and every time we have a new model release, it seems like things get a little bit better and a little bit better. But LLMs can still sometimes struggle with complex decision trees or following multi-step processes or maintaining the right context over many steps and then consistently getting the same execution every time. And this is why at Mastra we started with building workflows. Workflows are kind of an important primitive of the Mastra framework because with a more deterministic workflow, you have higher reliability, you have a more clear execution path, so it's easier to debug and figure out where something went wrong. Because you have a more structured process, it's easier maintenance. You have type safety throughout. There's a lot of benefits to having a very clear defined workflow. You have human in the loop capabilities, so you can actually like have a human validate that this is making the right decision before it continues on. And then you have kind of fine-grained control. So we like to use this analogy of like crawl, walk, run. And there's in the state of LLMs today, we kind of look at these three paths of, where are we at on this path and how do we, what applications kind of fit into this. So we like to think of, the like if you're crawling or if you're just getting started, agentic workflows are usually the best on-ramp. When you get to the point where you want to walk, you maybe want the LLM to make decisions so it can choose to call its own tools and maybe it has a reasoning loop to make decisions so it can kind of integrate with external systems, but it's making the call of when to make those do those decisions based on a system prompt that you give it. And then run, which is like the dream state, is that you have these complex multi-agent systems that can hand things off between each other and work together, mostly autonomously with very little to no human interaction. And so this is like it's funny because the first time I made this slide, it's changed maybe a little bit, but it's still kind of funny how it all fits together. So we like to think of we want to have primitives within the Mastra framework. And we'll talk about Mastra a little bit more in a second for those of you that are maybe new to Mastra and don't know what it is. But a lot of this applies to, other ways to build AI applications as well. But we have three primitives that kind of map to these different goals that you might want to do. We have workflows, which are kind of like a really great entry point. We have agents, which allow you to let the agent or the LLM make decisions and call tools. And then we have what we call our agent network, which is the ability for agents to be connected to each other and kind of share information back and forth. And so you kind of have the whole agentic spectrum covered with Mastra. The dream, of course, is way out here you just have these complex agent networks that you can put a small system prompt and spin up a bunch of agents and they'll just go do the work. But the reality is that oftentimes, and it does vary depending on the use case, but more often than not, you have to go further left than you would expect to get the right results. So you might, for some applications, maybe you can use multi-agent systems. Deep research is one that does really well with multi-agent systems, but they're more complex, they're less reliable, and so more and more frequently, the reality is you're somewhere between choosing just straight workflows and using agents with some kind of guardrails of decision making and tools that they can call. So we often, encourage people to either start with agents and then add workflows in when there are certain parts of your agent that aren't working well, or maybe even just start with workflows and see if you can get the results you want when you have a little bit more control. And this is kind of what I was mentioning, it's kind of the most challenging choices, like where do you start? Do you start with a workflow? Do you start with an agent? And how do these things work together to help you build more complex systems? So we like to use this kind of analogy of like a customer success team or, like often called like a customer engineering type team or something. So this, if you think about it from like a technical perspective, it kind of works as a good analogy. So imagine that I was just hired as like a customer success engineer. I was going to help people implement some kind of technical tool. Well, on my first day of the job, I'm probably given a set of tools like Slack or Notion or Zendesk or some kind of support system. And then I'm also given these playbooks and runbooks that say when an issue comes in, go through these steps, maybe reach out to these teams based on these conditions. Here's how we do things here. And the playbook or run book allows me to kind of follow the procedure, but me as you know, the customer success engineer, I do have to use my judgment. So in this analogy, the engineer is the agent, the playbooks are workflows or more deterministic steps where there might be some decision making in there, but the path is relatively well determined ahead of time. You kind of know the process. And that's how these agents and workflows and tools kind of all work well and interchangeably. You can kind of think of it this way as a good analogy. And, often I think this isn't anything surprising to people. Typically, the highest performing teams have better documented processes and they kind of have the right more playbooks written out. And so we like to think of like, why would an agent be any different? If you can give them more structured playbooks or run books, then your agentic systems are going to be more reliable. Just like a human would be more reliable if you gave them better tools and better documentation and better run books. So the other thing that we'd like to say is that you should really treat an LLM as kind of like a smart, eager intern. And I do think that this has changed a little bit over the last 6 months where there's more that they can do now than they could 6 months ago, but it's still not always reliable, right? Sometimes they will kind of go off and do amazing work, but sometimes they'll come back and they'll just have completely missed the mark, right? And you probably experienced this if you used, ChatGPT or Claude or Gemini, right? Sometimes it's amazing, and sometimes you kind of shake your head, or especially if you're using tools like Cursor to write code. And so I think you should kind of, if you think about them this way, then it kind of helps you frame like the guardrails you would want to put around them to make sure that you don't give them too much autonomy, because you're likely to get the more autonomy you give an LLM, the more likely it's going to make a mistake. And so let's talk a little bit about Mastra for those of you that are maybe new, haven't attended one of our workshops before, or not as familiar. Mastra is the open source AI agent framework for TypeScript. So we have, as I've mentioned so far, we have agents with tools, memory, tracing. We have workflows that you can do human in the loop, and it has a really simple API. And we're going to spend a lot of time on that today. It has evals for really tracking and measuring AI output. You want to make sure you're getting consistent results, which I mentioned before is very challenging. We have storage for RAG pipelines. It's all kind of bundled into a local development playground, which we'll see as well today. Our big theory around Mastra workflows is you really shouldn't have to learn graph theory to build an agentic workflow. And, if you've ever used any kind of like state machine or graph theory, it's kind of complicated of like how you wire these different nodes together and these edges and nodes. And it gets really confusing, especially in complex systems. So with Mastra's approach, we want to have a simple, intuitive API so you can spin up workflows in a much more easily readable way. And we want to have a code-driven definition so you have full control over exactly what's happening, but also visual feedback. So you can see and you can understand visually, because even if you can make the API very simple, if it's a complex workflow without some kind of visual representation, it's very difficult to understand exactly what would happen and how information moves through the workflow. So we're going to go ahead and build some workflows. I'm going to answer a couple questions before we do, and then we will see if we can get started and actually see these things in action. All right, so a few questions. What Masab asked, what's the value proposition against LangGraph? It's kind of that last slide, I guess. If you want to learn graph theory, LangGraph is, pretty good. There are people that like it. We kind of think that there's simpler ways to do it. It doesn't have to be so complex. The on-ramp to actually building something useful and relatively complex should be easier. That's one of the reasons we built Mastra. Will a recording of this be shared later? Yes, it's actually going to be shared right now. If you go to our Mastra-AI YouTube page, you will see it's live and it'll be immediately available on our channel after this. And I'll also send out an email to anyone that registered with links to this presentation and the GitHub repo we'll be going through. All right. So a couple questions. All right. So Ivo asks, in the context of streaming with the open router response output, how can I surface messages from a workflow upwards to an agent, assuming that the workflow is started from an agent? This is a really great question, Ivo. So we have a blog post that's probably about a little less than a month old, and we just released what we're calling our vnext stream method or function, where you can call agent.stream and it's actually agent.stream vnext because it's kind of experimental right now. But if that agent then calls tools or workflows, any of those steps inside that workflow or tool is passed up into the stream. So there is a way you can do it. Um, if you look at we do have, like I said, a blog post. I think it's probably about 3 weeks old, maybe. It's called, something with streaming in the title. And then we will be having even more documentation come out as we make it not, move it out of experimental and kind of replace our existing stream implementation so you can do those much more complex outputs. Let's see. There's another question here from, I think it's Juiced. Thanks for crafting Mastra. We really enjoy building with it. We're using workflows to build complex human-in-the-loop interactions. They use suspend and resume to collect user input, and it seems the agent and workflow integration is not suited for this use case. It starts, but it cannot resume. So this is a good call out. Human in the loop with agents is a little bit more complex, but we're actually solving it right now. So it should be out. Can't commit to an exact timeline, but it is something we've been working on because, yeah, Juice, we have been hearing that you not only want to just call the workflow and have human in the loop, you might want an agent that can call a workflow, and then you need to basically pause at that point and then be able to resume the entire agent interaction from that workflow. And so it is kind of more complex, as you can see. There's like more handoffs that need to happen, but we are working on a good, easy solution for that. And then, all right, so do we have any plans of implementing any code generation agents, code act? So the answer to that is not today, but so we are working on a new template. So Mastra has a bunch of templates that provide examples. If you go to mastra.ai/templates, we're going to be adding a code generation template for just people have that same question. They want to build coding agents. A lot of our users are building different types of coding agents, whether they're app builders, website builders, um, yeah, database, query builders, all kinds of different tools. So we are working on a template that will try to show a little bit more information on how to do that. All right, so we got a whole bunch of questions, a lot of good questions already, which is great. We do need to make sure we get into looking at some code. So I'm going to answer maybe one more here. So is there a rubric for which approach to follow depending on the use case, agent-led or workflow-led? There's definitely not a set rubric, Sandeep. I think that what we typically recommend is if you are starting with a chat interface, the agent led is probably easiest to build because you kind of are talking with an agent, but then there might be certain tasks that agent needs to do that should be in a workflow rather than just, built into the system prompt. If you're if it's more of like a application that has potentially long running things that happen, something happens in your app, all these things need to go off and do something in a more structured way. Having it workflow led is usually better, but it is definitely very use case specific. And then one more, and there's a couple more that we will try to get to here in the end. But what's the best way to deploy and run long running tasks like deep research? This is where workflows really comes in. Our goal, especially with we do have a cloud product to make sure that you don't run into like serverless timeouts and things. A lot of deployment providers are trying to solve this though and allow you to have these long running tasks because sometimes these tasks might run for 5, 10, 15 minutes if you have really deep research you want it to be able to do. So I would say you got to look at the deployment providers, see where they're, if they have timeouts, see what their resources they give you are, and then you can kind of make a decision from there. Mastra works well with all of these different providers, but you do need to kind of look and see what you're getting because it does kind of matter. All right. So let's go ahead and let's start to look at some code. And this code is available. So I'll actually just share my whole screen and I'll show you the link here. So you can actually go and see it if you want. Let me get it pulled up. And feel free to continue asking questions along the way. I'll try to get to them all, but we do want to get into actually looking at some code. So let me So if you go to the Mastra-AI GitHub, there's a workflows-workshop repo. It's public. You can download the code and see it there. But I have this thing running locally, and hopefully you can all, this is legible enough. Maybe I'll make it just a touch bigger. I'm just going to run npm run dev, and then we will look at the playground. So again, Mastra comes with a built-in playground, so you can visualize your workflows, you can test them, you can get observability into how they're actually working. And I will go to the playground, and this hopefully is big enough. But we have agents, so we have a whole bunch of agents. We're not going to spend too much time, but we will look at a few of these. And we have workflows. And so you can see we have a bunch of different workflows we're going to talk through. And the goal here is I just want to show you some examples of workflows and how they're written, and we can talk through the code and then answer questions along the way. And then, as I mentioned before, please feel free to download this and try it out, play around with it and see if you have any other questions, afterwards. All right. So let's go ahead and look at this first one. We're going to start with something very simple. This is a two-step workflow, as you can see. Step 1, fetch the weather. Step 2, plan activities. Okay, not too much makes sense. We can actually add an input over here and run it. So in this case, it is just the city we want to get the weather for, and then it's going to plan activities based on that city. So I'm not in San Francisco today, so let's see what the weather is, and we will see what activities it would say might be good based on the weather. The nice thing about this playground is we can see the inputs. The city was San Francisco. We can see the output. So this is what this step returned. So it tells me the temperature in Celsius, the condition, the chance of precipitation. And then you can see that this gets passed into here. So we can see the output, or the input of this step was the output of the previous step. And we can see the output, which is going to be kind of a messy string, but we'll take a look at what it actually says here in just a second. And we can also see the actual trace. So if we want to get really detailed about what happened, you can see that workflow was executed, it ran this step, and we can see the individual stream that happened in this step. And we can see, the input, the output, and you can see here, it's a little bit better formatted at least. So it tells me I could do an outdoor Alcatraz Island tour, for instance, today. So that is a really simple workflow. So let's actually take a look at the code and see how this was implemented. And I do see we have a bunch of questions. We had someone raise their hand. I'll stop after maybe after the next example or after we get through the code of this example and answer a couple of them. Okay, so if we go into the code, and hopefully this is big enough here. Mastra comes with, by default, you have a Mastra folder. We have agents, tools, and workflows, and that corresponds pretty accurately, to what we saw in the playground. And we kind of built it that way, so it's very easy to kind of move back and forth between code or the playground. And we're going to go to our first step. And when I'm looking at workflows, I usually like to start at the bottom and work my way up, because typically you kind of define the steps above, and then you often just define how those steps interact towards the bottom. So this is the chunk of code that really wires up the diagram that we saw. So the first step is we're going to call this create workflow function. We're going to tell it any steps that could be used, so all the possible steps of the workflow. We give it an ID. This could be anything we want. We have an input schema, which is, in this case, it's the city, and it's a string. And this text here is displayed in the playground, so you can kind of see it. That's the input form we used. And then the output schema, which is just a string with activities. And then this is what actually wires it up. We have an API method called then, which is just like, then this happens, and then this happens, and just kind of like a chain, right? So then we fetch weather, and then we plan activities. So really simple, just 2 steps. We could just chain a whole bunch of thens together and have a whole big chain of steps. And essentially it's just calling peer functions that we will show in just a second here. But we do want to make sure we always commit it. So the reason the commit is needed is because it allows you to just continue and maybe conditionally chain events depending on certain situations or whatever. But you can kind of just add to this chain, and then once you're done, you commit it, and then you can export it, and it will then show up in the playground. We do have to, in our source Mastra index file, you'll see here it's always pretty much the standard practice is putting it in source Mastra index.ts, but we export the Mastra class where we define any workflows, any agents, and this is what is used to power the playground. But this, if you're building an application, this is also a class you can pass around your application. So you can pass around this Mastra class that gives you access to call all the workflows, all the agents you defined, and this is where you can bake in memory, a storage, you can customize the server that gets created. So you essentially have a lot of flexibility to pass this class around your application. So I like to show that. We're going to just be going through these 5 workflows today, but that's kind of how it's all wired up and how the playground knows about all these things. So if we go back in the code, let's look at what fetch weather and plan activities actually do. So up at the top, we're going to have this forecast schema, which is just saying this is the output of the forecast. We have this create step, which is called fetch weather, and it says it's going to fetch weather for the given city. It has the input schema, which is the same input schema that we had when we created our workflow, because it just kind of inherits that step. And then the output schema is what we defined right here. And then from there, it's just a function. Like this is just a JavaScript function. We can write any code we want here. We'll go through what this does really quickly, but just know that this can be anything. You can have it do whatever you want. In this case, we just make 2 fetch calls to 2 different weather APIs and then combine that into one object that we just return. And that's all this step does. Go out to a couple APIs, get the weather, transform it a little bit, and then pass it on to the next step. The second step, plan activities, has the input schema, which is just the output schema from the previous step. And that's important because this gives you like the type safety of being able to show that each of these steps kind of builds upon each other, and it's kind of the input or the output of the previous step is the input of the next step. And so you know for sure that what you expect. It kind of allows you to really have confidence in the system you're building. And this one is, you'll notice there's a couple things that you get passed in this function. Get init data, input data, and this master class. So the get init data is the input data that came from when you called the workflow, right? We said that the city would needed to be passed in when we define this workflow right here. And you can get that at any step and just say, what was the input for this workflow? And we got the city out there. The input data of this specific step was just whatever the previous step output, which was that forecast schema that we saw. And you can see it has, date, max temp, min temp. And then we're creating a prompt. So based on the following weather forecast, suggest activities. And then we're using this master class. And again, I said this master class can just be passed around. It's also passed into each step. We're just going to get the planning agent, and we're going to call this stream vnext, which I kind of mentioned before, but you can also call .stream. These are just like, this is like a little bit better improved stream function that we're working on. But it basically just says, pass in this message, this user prompt, and stream this result back. And then let's write these chunks, and then we'll return the activities as a text string. And remember that is the output of this, right? Is just an activity string. And that's how this whole thing works. So it is, the nice thing about this, I could just have written this in a single function, but you have all the tracing and all the observability into every step. You can see the past runs, you can rerun examples, you can see production data coming in. And so if you're building an AI application, you want to know, is the forecast what's causing the problem, or is the agent itself causing the problem? In what situation, what data was passed in the agent that got it to, to potentially give you a wrong answer? So you can get way more visibility and way more reliability of your system. That's really why we built this. Okay, so that's step 1. We have 4 more to go through. We have 25 minutes or so. I'm going to answer a few questions, and we'll try to catch up here. All right. So Swan had a question on Open Router, and there might be maybe they found a bug or an edge case that wasn't working. Swan, I don't know if you went to our Discord, but there's kind of two options that we can help you out. If you go to our Discord and post a question in there, if you want actual help, or if you think you found a bug and you can actually uh, provide reproducible steps, please just create a GitHub issue, and then someone on the team will take a look at it. Because yeah, we are trying to improve and make sure that Open Router works really well because we have a lot of our users do use Open Router. Okay. So asking about some other live stream options. I like the idea. Um, but are there templates that we can hand an LLM to create customized agents for users within the app? So you basically want to create dynamic agents from a template. So Mastra provides you some tools to do that. You can build dynamic agents, dynamic workflows. We don't have a template for an example of how to do that, I guess. We have some documentation where you could piece it together, but it is completely possible to build an application where your users create agents and then use those agents in an application. We have a lot of our customers that do that. And Bach was having some questions running the examples folder. I would try copying the example out of the folder and running it standalone because yeah, it's a big mono repo. So just maybe try copying it out. Some of the examples link to individual repos for that reason. But I would also consider going to the mastra.ai/templates page, which I'll drop in the chat, because that's a way to go where you can easily see independent code. You can actually download the template and run it locally with one command. So I would recommend trying, using the templates page as kind of your first pass of getting examples. Some of those examples in that folder are a little bit more detailed and a little older, but they do provide some good information. But yeah, you might have to copy it out of the monorepo. Um, Carlos, auth is a good question. Oh, hopefully we'll have time to talk a little bit about that, but that is there we have a page in our docs about auth. That's a start for you to maybe look at. But there's a whole topic. There's a whole workshop on just auth in general. Because yeah, that is a good, very kind of a nuanced topic. So there's a good question about resume and suspend. We're gonna get to that. So I'm gonna answer that question here in a little bit. How do I optimize my workflows? Okay, so hopefully we'll get to some examples of that. Great question on we're going to answer show some human in the loop. Yeah, maybe we might need a whole agent and workflow auth workshop. That's actually probably a good idea. Will this repo get uploaded? It's already available. So if you want to get the repo, go to mastra-ai/workflows-workshop on GitHub and you can get that repo. Can you deploy Mastra on serverless stack like Lambda? Technically, yes, we have people that do it. There are trade-offs though, especially with how long running tasks and workflows and memory and things like that. But you absolutely can. There are some considerations and some things that, because it's not necessarily a pure node environment, that don't work depending on the packages you're using and things like that. But it can be done. We can deploy. We have people that deploy to Lambda or Supabase functions or all kinds of different edge functions. All right, couple more. Wow, we got a lot. So one question is, for each step, does the actual result always match the output type or schema that is defined? If the model returns something that doesn't match, what happens? Great question. We're not going to necessarily show this today, but if you look in our docs, there are things where you don't know, you can't guarantee what you're going to get. And so you can do some kind of like mapping basically. So you can map inputs and outputs. and then talk through or then like basically transform data so you can do some verification and kind of provide some fallbacks in between. Essentially, it's kind of like a mapping step if you can't guarantee the inputs and outputs. Uh, is there any way to create like a plugin system that encapsulates shareable workflows and agents? So Masab, that's a great question. I think you're looking for our templates. That's kind of exactly what it's meant to mimic in some ways. You have shareable templates, you can create a template, you could share it and someone could install and run those templates with those predefined workflows and agents. So I'm just going to pull that up because I've had to mention it a few times already. So if you go, you can see we have templates, we have community contributed templates when we're always adding more to this. And we're going to reorganize this a bit because we're getting so many. We'll have a bunch more that we're going to add here that are kind of official templates. But for instance, if you wanted a browser agent, you can just run this command and it uses this repository, it spins it up, and it's a completely running Mastra application. You can also one-click deploy it if you want to just play with it live without having to run it locally. So that's the nice thing about a template is it's essentially something that's shareable. You could just share the link to the GitHub, for instance, if you go here, and you could just pass in the template with with a public GitHub URL, and you can have basically shareable templates. So I think that kind of answers your question. It's kind of like a plugin system in a way. Okay, a lot more questions. We're not going to get through them all. So I'm going to keep going we're going to go through some more code, and then we'll stop and try to do a few more questions. All right. So this was a really simple, very simple workflow, right? Two steps, not too complicated. Everyone can kind of understand what that's doing. Let's look at something that gets to be a little bit more complicated. So it's still a weather workflow. We're going to fetch the weather, but dependent on the chance of rain. So if we look here, if precipitation chance is greater than 50%, we're going to do this branch. If it's less than or equal to 50% or 50, we're going to do this branch, which you can see if it's going to rain, we're going to do indoor activities. Otherwise, we're going to plan just the general activities that could include both. And then there's this step here that we'll talk about. I mentioned it briefly, but sometimes you need to take multiple steps. You need to map it together, provide a single output. And so that's what this does. So let's run this. If anyone knows somewhere where it might be raining today, please tell me, because it's always nice to see both examples. It's probably not going to rain here in Sioux Falls, I don't think. And you can see, yeah, less than 50% chance. And it's going down this branch and it does the mapping. And I can, of course, take a look at the activities that it planned, the weather. I can open the entire workflow execution so I can see the payload from each step. So step fetch weather, here was the payload that started it. Here was the output. Here's the plan activities. And so you kind of get this JSON object out as from the workflow. Here's the output, and then here was the mapping. And all the mapping does is just, take those two steps, make sure that you're getting a single output from the workflow. So someone says, okay, London. That was the first one. Let's try London and see. Yes, we did it. Thanks for the suggestions. But as you can see, now there was a higher chance of rain. Let's see what the actual chance of rain was. Precipitation chance was 100%. It was definitely going to rain today. Um, so yeah, and it went down the other path, right? And of course, we can dig into the individual trace. We can see that, fetch weather, plan indoor activities. We can dig into all the minute details of what happened in each of these steps. But it's pretty straightforward to kind of debug how the decision was made, what happened. And if I do want to see, I can see past runs. So I can see and click between what happened in each of these past runs. And I can see the inputs and outputs of each step along the way. And if you did raise your hand, like I will try to get to you, but I do want to make sure we have we haven't got through all the code yet. So, and we have a lot of questions. So I probably won't be taking time for answering those. Please drop them in the Q&A though, and I will try my best to get to as many of them as we can. One question from David that we're going to talk about, I guess, so I'll just answer it. Is the workflow built through code statically? In this case, yes, but it doesn't have to be. you could define a workflow and dynamically build that workflow based on some data from your database, for instance. And each time you run the workflow, it could be dynamically built and run. It doesn't have to be a statically built workflow. But in most cases, like if you can make it static, you should. And obviously, you can have dynamic parts of the workflow. You know, this step could go get dynamic data from the database, but the actual structure of the workflow, if it can be static, is better, but it doesn't have to be. All right. So again, we're in step 2 now. This is the second example. We have this create workflow kind of at the bottom of this page, and we'll go up and see what these steps do. The input schema is the same. It's just a city. The output schema is the same. So we call .then, but we're introducing this new API called .branch, and that is where we're kind of creating that branch, right? It can go one way or the other, and this is basically just an array of uh, basically a pair that's first the condition. So in this case, the input data of this step, which comes from fetch weather, right? Fetch weather, we know if we look, it has a precipitation chance. You can see here in the type. So if that precipitation chance is greater than 50, call plan indoor activities. If it's less than or equal to 50, call plan activities. And so this is just a comment of like what the output of each of these steps are going to be. You're either going to get plan activities or plan indoor activities. So when we looked at that big JSON execution, it's one of those is going to be there. And so then we're going to just do this mapping step where we're going to say we want to map to this, we want to output this object called activities. It's going to come from one of these steps. The path is going to be the same because it's just activities. We could have an entire, we could custom write a step to do some whatever logic we wanted if these inputs or if these outputs weren't the same, if we didn't have as much control, maybe we'd have to do some custom logic to kind of like combine these. But map is just a handy function to kind of map data that has similar outputs. If it didn't have similar outputs, we could just create another step and kind of do that mapping ourselves a little bit. All right, and then we just commit the workflow and then we export it. But if we want to look at what these steps do really quickly, it's going to be about the same. We have a fetch weather step, which we already looked at before, so we're not going to look at that. We have plan activities, which again is basically the same as before. And plan indoor activities looks almost the same as plan outdoor activities, but we have a different prompt. We could use a different agent. In this case, we use the same one, but it just is basically a way to show that you could have, different agents or different prompts depending on different conditions. And that's it. So that is number 2. Let's answer a couple more questions. We have about 15 minutes left, so I'm going to keep moving pretty quick here because I think we have, 17 open questions. So I don't think we're going to get through them all. So I do apologize. I'll get through as many as I can. All right. So question is, can Mastra work with dynamic input schema? It should be able to work. I mean, it works best with a predefined schema if you know that, but there are ways. So we have something called runtime context where you can have more dynamic schemas and such that are kind of passed into agents or passed into tools. And so I do look up runtime context if you do need something that's dynamic. And that's kind of basically to pass context that's happening based on runtime conditions, right? That could be like the state, of a certain user in the database or whatever. You can basically pass in like for this specific user should only have access to these tools. That type of thing can all happen through runtime context. It's a little more complicated to wire up, but yes, you can totally do that. Okay, we answered that question. Can Mastra workflows be a replacement for N8N? Yeah, we do see, we actually have some users that use Mastra agents to call N8N workflows. We have some people that are using N8N and then decided that they want to use Mastra workflows. It is similar. N8N is much more of like a low code builder that adds some components to allow you to write code. But if you do have more complex systems, it can maybe break down because you got to install packages and it's a little more complicated to do that all through a UI, and you can't actually commit that code to Git and have like a deployment pipeline, so it's a little more complicated. Mastra goes the other way though and gives you access to the code from the beginning. It gives you like the UI and the visualization in some tools, but it's not really a low code workflow builder. So they are similar, but kind of coming from different ends. Is there a way to integrate third-party enterprise apps in the workflow via MCP? Yes, you could use one, you could just use if they have an SDK, you could create a step and call their SDK directly. If they have an MCP, Mastra has an MCP client, and you could then use that to basically call the tool from MCP. I don't know if we have a workflow that uses MCP, but we do have a bunch of agents that have examples of MCP. And if you look at some of our templates use MCP. I have not seen the steps attributes. I'm not sure which one you're talking about here. So, Juiced, you're answering a question. I'm not sure exactly what you're referring to here. So, if you can point me where you saw that, I can maybe describe what's happening. And Carlos, you're asking about auth. I think it's just auth needs to be its own topic. So, okay, we still have a lot of open questions, a lot of questions I'm not going to be able to answer, but we got to keep going. So we're going to move on. We're going to try to go quickly. So step three, concurrency. So in this case, um, we could we're going to fetch weather. This one, we're going to, if the chance of precipitation is greater than 20, we're going to run a nested workflow. So in this case, we're going to run these two in parallel and then synthesize the step. So you can kind of wire up workflows together. And this is a nice way. So if you have really complex systems, you don't want one super complex workflow that's hard to follow. Oftentimes you want to break these into like sub workflows, like you do with functions and classes and methods, right? You don't want one that just it gets overly complex, it's hard to follow. You kind of break them up and know that, okay, this specific workflow does this thing, but we're going to inject that workflow into another workflow. And so we're going to run London again because that, we know has rain. And you can see it goes down this path. It's running this nested workflow. So it's going to take a second. And then it's going to do the same mapping. And we can see the output is the same. The input is the same, but it actually did this, this nested graph. And so I can see the output of each or an input of each step. Let's look at just how this sub workflow was defined, because I think that's very interesting. So if we go to step 3 and we go down to the bottom, we have our workflow, same input and output schema. We define the steps. One of these is not actually a step, it's an entire workflow. So the nice thing is you don't just have to pass a step, you can pass a workflow as a step. And so first we fetch the weather, then we do our branch condition. But in our branch condition, one of them is actually just runs an entire workflow. This workflow, of course, does have, by default, the input of this workflow should match the output of this previous step. Otherwise, you'll need to do some basically mapping of that data first. But you can see how it gets very dynamic. You can build very complex systems with this. So we're going to keep moving because I know we're running out of time. And I do want to get through all of these because this is probably one that a lot of people want to see is this suspend and resume. So there's three very simple workflow, but it does have this human input step. So this is going to say a vacation planner. So I want to go on a Caribbean vacation. I'm going to click run. It runs. It provides some options. So it's going to call an agent to provide options, and now it's human input. So this gives me some options here, some suggestions. Bahamas, Jamaica, Dominican Republic. Let's go ahead and say I want to go to the Bahamas. So the selection of the user, I'll pass in and say I want to go to the Bahamas. It'll resume. And then it passes into another agent that takes my response and the previous suggestions and then plans a trip. So again, this is just a very simple human input example. And you can see how it works in our UI, but you could also wire this up to your applications, right? Where you trigger a workflow, you get to a point where you have to suspend it, and this stores this state. So I could leave this and come back a week later and pass in the right human input, and it would all pick back up. So it basically saves the state in whatever storage mechanism you specify in your master class. So your state of your workflows is always saved. If we want to look at this code really quickly, we'll go down to the bottom again, generate suggestion steps, human input step, then travel planner step. So the only thing that's really different here is what is this human input step? So let's take a look at that. It has an input schema, it has an output schema, but it also has this resume and suspend schema. Means if it gets into a suspended state, what do I need to continue this step? Suspend says if I call suspend, I'm going to pass this object back to the front end. So the front end can then decide and pass enough information to the user for the user to make some kind of decision, whether this is like a drop down or a free input or something, they're going to pass some information back. And so it's going to pass like the location descriptions, and then I have to pass in a selection, which is just a string. So what happens is you can see we're using resume data here. If we don't have resume data yet, that means we haven't suspended, we haven't captured input. So we're going to go ahead and call suspend, and we have to return something. You could just return the results of suspend, but you have to return something that says we are going to suspend the data or suspend the workflow. Here's the output that we're going to send to the front end. And then the next time it calls a step again, it's going to skip this and just go in and pass the selection on to the next step. And then this travel planner is just going to call an agent here, this travel agent. It's going to pass in whatever text we typed in. So if we didn't type in, we might have to do some air checking. If we want to verify they did type in an answer, we could do that here in suspend. We could say, check it. If it's not in the original suggestions, suspend again. And it will return some kind of response. So there are ways to kind of uh, make sure you get the right answer or the right output. All right, the last one we're going to look at really quick, and then I'll answer a couple more questions, is this like do and tell. So do and tell is basically a way to loop. This is just a really simple example. I can input a value, I can run it. It's going to do a bunch of steps. If I look at the console, you'll see it just logs. One of these steps just does a log. It just loops until it gets to the number 10. It's doing some kind of like step plus a side effect. Really simple. But if you had to have something that looped until it got the right answer, looped until the API, if you wanted to have like a retry on an API call, if you wanted to have like a human input that would do until you get to a certain spot, you can basically use this to create loops. And this one is going to look somewhat similar here. We have an input schema, which is just a value, output schema is a value, do and tell, and we dynamically create this workflow, which is, I mentioned you can dynamically create a workflow. So do and tell, we're just going to do this workflow that increments. So it's going to first increment the step, then do the side effect step. And it's going to keep doing this, keep running this workflow, this sub workflow until the input value is greater than 10. And all this increment step does is add one, the side effect just does a log, but it just shows that there's like you can run multi-step workflows on a loop until you get to a state where you are comfortable with the answer, and then you can kind of continue on. All right, so we had to kind of breeze through that very quickly, and we're going to answer as many of these questions as we can, and I can stick around for a few extra minutes for those of you that are still here. All right, so we're going to kind of start at the Q&A and work our way up. All right. How do you fix the capability of low capability models using tools incorrectly? I still have a lot of issues. We do have this thing called our compatibility layer, and it's meant to do that, to try to help with that. We both try to help with input for structured output, but also for tool calling. And so Mastra tries to handle that, but it is a problem, right? If you're using a really low powered model, it's more likely to make mistakes. So that's not something we can completely solve, but we do have some tools that help you get significantly better accuracy. And so you can look at that as an example, or you can, Mastra has it built in. Can we create like basically a voice pipeline, speech to text, an LLM, text to speech? We do have some voice primitives. It's not, LiveKits definitely has like a little bit more low level than us, but we do have real-time voice. If you search for real-time voice in the docs, we do have some docs around making real-time voice or wiring up your own voice pipeline. Okay, we answered that. Yeah, how do you handle multi-agent communication and make sure there's a recursion limit? There's two techniques that people typically do when they have multi-agent systems. One is you limit the maximum steps, or one is you basically have an end state condition, but you do have to kind of often use both, like a high maximum number of steps and an end state condition to kind of, otherwise you can get agents that just go on forever and rack up your token costs. So Eduardo is exploring dynamic tools. Is it possible to have dynamic steps? So you can use, so there's a couple options for passing dynamic data. It's nice to have the structured input and output schema, but if you don't, you can pass values in runtime context between steps. You don't get the type safety, which is one of the whole reasons you want to do this. But if you truly have really dynamic data that could come back, and you can't structure it in a way where you say, oh, it's going to be, this value or something like that. It could be truly dynamic. You can use runtime context, and it just gets passed into each step, and you can basically write to that like it's a key value store between steps. I wouldn't recommend it if you can get around it because you lose type safety, but it's there. It's a tool that can be used. All right, so I'm gonna share a couple slides here just as a way to end this thing, kind of put a bow on this. There's some questions I didn't get to. I'll try to answer a few more after this. But you please, if you want the project, you can get that on GitHub. Please give Mastra a star if you haven't given the Mastra GitHub a star. We appreciate that. Come to Discord with some of these questions. There's a whole bunch of questions I didn't get an answer to. If you have a question I didn't answer it, please drop into our Discord. Someone on the team or myself will try to answer it, and we'll try to help you out. Come to more of our events. It sounds like we need to have an auth event, so we'll maybe have to plan that for the somewhat near future and talk about an auth workshop and how to handle workflow agent authentication and workflow authentication. And then follow me on X or Twitter, connect with me on LinkedIn, give us a star on GitHub, as I mentioned, and yeah, that is it. Thank you all for attending. I'm going to grab one more of these 10 questions that are left. I feel bad leaving all these, but I know people often have to go. So really appreciate everyone for coming. Thanks for attending this workshop, and come back again. But let us know in Discord if we didn't answer your question, and we'll try to answer it there. All right, so one last question to end it on. Okay, so question is, so these workflows can be called as a backend API from the front end. Do they need to be deployed as servers, or can they lie as serverless in the front end? And so the answer is so they do need to be run. They can't be run from like your client, but they can be deployed in a serverless environment. So you can actually run Mastra inside Next.js, for instance, and you could deploy it to somewhere like Cloudflare or Vercel, and you may have an API route on your Next.js app that calls the Mastra workflow. So you wire up the front end to call your API route. That API route is run in a serverless environment, perhaps on Vercel, and you don't have to you basically have one application you can deploy. There is a lot of benefits to having a separate backend and from a separate front end, and where you could deploy your front end and deploy Mastra as its own standalone server. It uses Hono under the hood to give you an API for all these to call workflows, to call agents, to call any of the primitives. So then you basically have a separate backend, like basically an AI backend to your front end. And then your deployment pipeline is a little more complicated that way, right? But you have much more flexibility as well. So that we see a lot of our users do it both ways, depending on the needs of their projects. So Mastra supports both, and yeah, it can be used either way. So great questions. Sorry for the people that raised your hand that we didn't have time to answer everything. Again, appreciate you all for coming, and you'll get an email with a bunch of these links here in a few hours, and we hope to see you all again. We'll see you next time.